Hello everyone, welcome to my channel ankeecodeverse. Today we are simplifying complex coding with solid principles. This rule boosts code efficiency and reliable. So get started. The solid principles are a set of 5 design principles that help developers to create, maintain flexible and scalable software. These principles were introduced by Robert C. Martin and are widely used in object-oriented programming. Let's explain each of the solid principles with example. There are 5 types of principles, which is single responsibility principles, open close principle, risk of substitution principles, interface segregation principle, dependency inversion principles. Single responsibility principles. That means a class should have only one reason to change, meaning it should have only one responsibility. This means that each class should be focused on a single task and do it well. That does not mean you have only implement one method, but each class needs to have a focused specialized role. First, create a playground file, then proceed the next step and give it a name. Create on user manager class, and this is an example of violation of SRP. First, we create a function which has two type naming keys, username and password. Under this function, we have implement the authentication logic. Second, we create a function that is update profile and implement with the user structure. So we can create a user naming structure and put the profile management logic here. Adhering to SRP by separating the two responsibility into two different classes. According to violation of SRP, you have a user manager class that combines two disconnect responsibility, user authentication and user profile management. This violates the SRP because it couples two different concerns in a single class. According to adhere to SRP by separating the two responsibility into two different classes. First is Auth Manager. This class is responsible for user authentication. It contains the login method which handle the authentication logic. Second is Profile Manager. This class is responsible for user profile management. It contains the update user profile method which handle the profile management logic. Open closed principle. In simple terms, open for extension but closed for modification. This means that we should be able to add new features to our software without having to change existing code. Open for extension, you should be able to extend and change the behavior of the class without efforts. Close for modification means you must extend a class without changing the implementations. Let's start the example of open close principle. First we create a protocol that name is shape and create a function that naming is area and return a value of double. Now we create a struct circle naming and inherit with the shape protocols. Now let create a radius with the naming convention of double. Brief explanation of OCP steps. First, protocol definition. We define a protocol called shape which declare a method that name is area that return a double. This protocol serve as a abstract base for different shapes. Circle struct implementation. We create a circle struct that conform to the shape protocols. It has a priority radius and implements the area method to calculate the area of the circle using the formula pi multiply radius and multiply radius. Rectangle struct implementation. We create a rectangle struct that also conform to the shape protocols. It has properties of width and height and implemented the area method to calculate the area of rectangle using the formula width multiply height. Creating an instance of rectangle, you create an instance of the rectangle struct named object rect with the width of 15 and the height of 5. Re- Calculating the area of the rectangle, you call the area method on the object rect instance of the calculate the area of rectangle and store it is in the rectangle value variable. Print the result. Finally, you print the calculation area of the rectangle using print statement. LSP ensure that subclasses can be used interchangeably with their parents class, promoting code reusability and maintainability. This means that we should be able to use a subclass in a place of its parents class without causing any problem. Objects should be replaced with instance of their subclass without altering the behavior. In the simpler terms, if the class is a subclasses to another class, it should be able to use interchangeably with its parents class without causing issue. Suppose you have a base class called bird which represent various type of birds. The bird class has a method that called be fly and fly. So override the method here. So violation of LSP, we have a base class bird with a fly method. We have a derived class ostrich that override a fly method to indicate ostrich can't fly. We have a function makeWordFly that accepts a parameter of type bird and call the fly method on it. The violation of LSP occurs because the behavior of the ostrich subclass different from the expected behavior of the generic word. When you pass an instance of the ostrich to make bird fly, it prints that ostrich can't fly, which is inconsistent with the behavior of a typical bird. Adhering to LSP, we define a protocol bird that indicate a property is flying, the type of boolean. We create three struct, flying bird, non-flying bird, and ostrich, all of which conform to the word protocol that implement is flying property accordingly. We have a function make word fly that accept a parameter of type word and check the is flying property to determine whether the bird can fly. In this adhering to LSP code, you use the word protocol instead of the concrete classes. When you call make word fly with instance of the flying word and ostrich LSP, it correctly print whether the word can fly or not based on the is flying property. This address to LSP because you can substitute any type conforming to word LSP without altering the expected behavior, ensuring consistency between the base type and its subtypes. Interface segregation principle. Client classes should not be forced to depend on interfaces that they don't use. This means that we should create specialized interfaces for each client so that they only have to depend on the method that they need. An interface is called fat when it has too many methods which contain more information than we really want. Violation of ISP. The worker protocol defines two methods work and eat. This means that any class that adopt a worker protocol is obligated to implement both of these methods. the programmer class adopt a worker protocol and provide implementations for both work and eat method. In this case, the worker protocol has both work and eat method, but not all worker may need both of these methods. For example, a programmer might need both, but a different type of worker might not need an eat method. Adhering to ISP, we have defined two protocols, workable and eatable. Each represent a specific behavior. Workable includes a method work for doing work and eatable includes a method eat for eating. We have a class multiple programmer that conform to both workable and eatable protocols. This class implements both work and eat method, which means it can work and eat. We have another class single programmer that conform only to a workable protocol. This class implements the work method but does not implement to eat method because it doesn't need to eat according to its role. Dependency inversion principle. High level modules should not depend on low level modules. Both should depend on abstractions. This means that we should decouple our code so that the high level modules don't have to know about the detail of low level modules. Both should depend on abstraction and abstractions should not depend on details. Details should depend on abstractions. Violation of DIP. We have a data service class that directly fetches data from specific data source. We also have a user manager services class that depend on data services to fetch user data. This create a tight coupling between user manager services and data service. Violation of DIP because the high level module means user manager services depend on the low level module means data services. Adhering to DIP section, we define a protocol data fetching, which is a type. It should be data fetching that includes a method fetch data for fetching data. This is the abstraction that high level module will depend on. We have a data services user class that conform to the data fetching protocol and provide an implementations for fetch data. This class represent a low level module that know how to fetch data from a specific source. We also have a user manager DIP class that take the data fetching object as a dependency through its constructor. This class adheres to DIP because it depends on the abstraction data fetching, not a specific implementations. Inside user manager DIP, we have used the injected data fetching object to fetch user data, making it flexible and decoupled from the specific data source implementations. Solid principles are important because they help us to write code that is more maintainable, scalable, and adaptable. Code that follows solid principle is easier to add new feature to fix bug in test, and it also less likely to break when we make changes to it. I hope this helped you. If you have any doubts in the comment section, and check out the description and download the live example for better understanding. Don't forget to like, share, subscribe. Thank you.